So in this video, I'm going to go over the 8.1 through 8.4 quiz. So first of all, it says AB is tangent to circle C. Well, if that's true, then there's a right angle right here at A because AC is a radius, and where the radius and the tangent intersect is a right angle. Then I'm going to go ahead and label these parts. It says AC is 18. Sorry, that wasn't very legible. So this is 18, and then AB is 24. We also know that all radii in a circle are congruent. So if AC is 18, then CD is also 18. And this is a right triangle. Well, if it's a right triangle, then we know that this side over here, CB, is the hypotenuse. So we're going to use our A squared plus B squared equals C squared. So we're going to do 18 squared plus 24 squared, and we're going to set that equal to CB, the whole side length over there squared. So this is going to be 324 plus 576 equals CB squared. Well, that's 900 is equal to CB squared. So we must take the square root of both sides to get CB. So CB is 30. So that is the whole length here. That's 30. So to find DB, we would take our 30 and subtract 18 from it. So that would be 12 is the length of DB. And again, you guys, some of you did not read the question. It said to find DB. So over here for number 2, we have two tangents that are originating from the same point. So we can say that GE is equal to FE. So we're going to set those two equations equal to each other. 1/2 x plus 4 is equal to x minus 5. Well, if we subtract 1/2 x from x, we get 1/2 x over here. We're going to add 5 to both sides, so that's going to give us 9. Now, there's two ways that we could deal with this. We could divide by 0.5, or we could multiply both sides by 2. I'm going to go ahead and multiply both sides by 2. So that's going to give me that x is equal to 18. Again, the question did not ask me to solve for x. It asked me for FE. So that means we have to plug that 18 back in. So when we do that, we're going to say 18 minus 5. So our answer here was 13. And what I saw with a bunch of my students is they were able to solve for x, but they did not plug x back into the equations to get the answer the question was asking for. With number 3, it says BD is perpendicular to AC, so I'm going to draw a right angle symbol there, and then FH is perpendicular to AG, so I'm going to draw another right angle symbol there. It also says that CA is congruent to GA. And so that tells me that those two chords must be congruent. So I should be able to say that BD is equal to FH. That means I can set those two equations equal to each other. So x plus 25 is equal to 20 plus 2x. I'm going to subtract x from both sides, so that gives me x over here on the right. And I'm going to subtract 20 from both sides, so that gives me 5 here. Once again, the question's asking me to solve for BD, so I have to plug that back in. BD was equal to x plus 25, so we're going to do 5 plus 25. So again, BD is 30. On number 4, when I taught this concept, I taught my students that we're going to do part times part of one chord is equal to part times part of the other chord. So what I'm going to have you all write first is part times part, because this is what you got to remember on the test, equals part times part of the other chord. So what I'm going to do is I'm going to do dt times tf. That's equal to gt times te. Now I'm going to go ahead and I'm going to put my measurements on this that were given in the problem. So this says dt is 7, et is 8, gt is 2x, and tf is 2x plus 2. So now I'm going to multiply dt, that's 7 times 2x plus 2, and I'm going to set that equal to gt, which was 2x, times te, which was 8. So that's going to give me 14x plus 14 is equal to 16x. Going to subtract 14x from both sides. That gives us 2x over here and 14 on the left. Divide both sides by 2. x is equal to 7. Again, the question didn't ask me for x, it said to find TG. So TG is right here. So TG is going to be equal to 2 times 7, which is 14. So with number 5, I see that we have two secants. And what I taught my kids again was outside of the secant times the whole secant is equal to outside of the secant times the whole secant. So let's talk about our letters here on that deal. So that would be MN is our outside, and MN plus NO is our whole, right? That's equal to ML is our outside of our bottom secant times ML plus LP. Now we're going to go ahead and measure or put our measurements on here. So MN was 6, NO was 8, ML was 7. So we're going to do 6 times 6 plus 8 and set that equal to 7 times 7 plus LP. This will be 6 times 14, and this is 7 times 7, which is 49, plus 7 LP. 6 times 14 is 84. Still got our 49 plus our 7 LP over here. Going to subtract 49 from both sides. That gives us 35 over here is equal to 7 LP. Going to divide both sides by the 7. So LP is equal to 5. And this time that is the answer because it's asking us to find LP. All right, number 6. I'm going to go ahead and just label this one first because we've got our process outside times whole is equal to outside times whole. So RD is equal to 11x, CD is equal to 7, BC is equal to 6, AB is equal to 15x, okay? And this time we're going to find AC when we're all done. So on this one, we're going to do outside, which is 7, times our whole, which is 7 plus 11x. Set that equal to 6 times 6 plus 15x. So this is going to give us 49 plus 77x. It's equal to 36 plus 90x. Going to subtract the 77x from the 90x. That gives us 13x. Going to subtract the 36 from the 49. That also gives us 13. So 13 goes into 13 one time, so x equals 1 here. Now once again, look what it asks us to find. We're trying to find AC. So AC is this whole thing. So that means I got to plug the 15 times 1 in there and then add the 6 to it. That's going to be 21. That's going to be our length for AC. Our next two problems have a secant and a tangent in it. So when we deal with the secant, we're going to deal with it the same way we did before. We're going to do our outside times our whole. Now with the tangent though, we're going to square that tangent. So that means we're going to do xy times xy plus xw. And then we're going to set that equal to zy squared. So let's go ahead and label this with our measures. We've got 18 out here, we've got 30 here, right? So we're going to do our xy, which is 18 times 18 plus, I'm going to call it wx because that's what we're actually solving for up here. Y'all see that instead of xw. And then we're going to take this 30 and we're going to square it. So 18 times 18 is 324 plus 18wx equals 900. Subtract the 324 from both sides. That gives us 576 equals, sorry, I did that wrong. I'm supposed to put the 576 on the other side of the equal sign, y'all. So I got 18wx equals 576. Divide both sides by 18, so wx is equal to 32. And that was what we were looking for this time. Okay, so number 8, a lot of people miss number 8, predominantly because they don't know how to square a binomial. So I'm not going to do our letters again. I'm just going to show you all this. So this is x plus 6 up here. Our s is x and ts is 16. So we're going to set this up by squaring our, I don't know where I got that 2 from, y'all. We're going to square x plus 6 And then we're going to set that equal to x times x plus 16. Well, I'm going to go down here and show y'all how to square this. So remember, if I got x in 6 and x in 6, let me do it like this. X times x is x squared, right? X times 6 is 6x. X times 6 is 6x. 6 times 6 is 36. These two can combine. So when we squared this binomial, what we got was x squared plus 12x plus 36. A lot of y'all, when you did this, you got x squared plus 36. Remember, that's not what you get when you square a binomial. You get a trinomial. So over on the right, we get x times x, that's x squared, and then we multiply the x times the 16, so that's 16x. You should be able to see immediately that these x squareds are going to cancel each other out. Then we're going to subtract the 12x from the 16x. That gives us 4x equals 36. Then we're going to divide both sides by 4. So x equals 9. Now this time, that really is the answer because RS equals x, thus it equals 9. So there you go. I was nice on that one. So on these next two problems, we're going to answer the question that was being asked, but we're also going to take it a step further and talk about what created the center. So on this one, my first question for y'all is, what is happening here? Is the circle inscribed or circumscribed? Well, the circle is inscribed, thus it's an in-center. That's the name of the center. It's an in-center because the circle is inscribed. And then the other question that I want to ask y'all about this is, what created that center? Well, I noticed that all my angles are being bisected. Those intersection of those angle bisectors is what created this drawing. So these are angle bisectors. Then when we go down here and look at number 10, on this one, again, is the circle inscribed or circumscribed? This time the circle's outside the triangle, so it's circumscribed. That means the center here is a circumcenter. And this question actually was, what was drawn to create the center of this circle? And in this case, I see that the sides are being bisected and they are perpendicular lines that are bisecting the sides. So in this case, it's a perpendicular bisectors. So you really should just be able to look at the drawings here to tell whether it's an angle bisector or perpendicular bisector, if that's the question that's being asked of you. So let's read this extra credit problem. Tethys and Calypso and Telesto are 3 of Saturn's moons. Each has nearly a circular orbit, 295,000 kilometers in radius. The Cassini-Huygens spacecraft entered Saturn's orbit from Calypso to Cassini. It's 83 million meters. And from Cassini to Telesto, it's 203 kilometers. Telesto is a point of tangency. Find the distance in kilometers from Cassini to Telephus, however you say that, y'all. So first of all, let's look what we have. So it says, so first of all, I noticed that this is in meters and want our answer in kilometers. So we're going to convert that. We would divide that by 1,000. So this is 83,000 here. And then the distance from the spacecraft to Telesto is 203,000. And y'all, I'm going to make from Telephus to Calypso X up here. So we're going to do outside times whole and set that equal to our tangent squared. So we're going to do 83, and I'm just going to do the 83 times 83 plus X. And then I'll put the zeros back on it when I'm done. And then we're going to set that equal to the 203 squared. So when I multiply 83 times 83, I get 6889 plus 83x. And then when I square the 203, I get 41209. Then I'm going to subtract the 6889 from the 41209. So that's going to get me 83x equals 343.20. Then I would divide that by 83. So x is equal to 413.49397. Now what am I going to have to do? I'm going to have to move my 0 3 places, so it's going to end up right there, because that's basically what I did when I took those zeros off. Now here's the key. The question asked us, how far is it from Kissimmee, that's out here, to Telethus, or however you say that. So that means we got to add these two measures together. So this was 413.493.97. We're going to have to add that to the 83,000. So that gives us 496,493.98. That was our answer, kilometers.